Hello, everyone. Welcome to the study season at TE Academy. Now, with the fourth session in dApp analysis, exploring the complex systems-oriented approach with Giuseppe Destefanis. Welcome again, Giuseppe, and welcome everyone to the session again. I'm glad you're here. We are in the fifth week of the study season. It's super exciting to see the courses progress, the live tracks progress, and I just want to let you know, in case you're watching this on Twitter or on YouTube, you can still register for the study season to follow Giuseppe's track or to follow all the other, in total, 8 live tracks at Token Engineering Academy. Register via tokenengineering.net and get full access to all the learning material, to the session recordings, to the GitHub repositories, whatever you need. And then you have the chance to mint a proof of knowledge that proves your newly acquired skills in this program. Before we start, 2 announcements. Next week, we'll run an event together with MetaGov, HyperCerts, open source observers, and TE Academy, and we'll discuss the future of crypto impact measurement. I mean, we are benefiting from public goods funding and measuring the impact of projects like ours and other projects who work on building public goods for crypto protocols, for example, at Optimism, at other layer 2s, at other protocol ecosystems, is something very important to further develop the sector. Big question is how to measure impact. To then appropriately fund and equip these projects with the support they need. And since we are working on a related topic in the study season with reputation-based weighted voting, that should also support and make funding for public goods in the crypto sector smarter. This is, of course, a natural topic of interest at TE Academy, and I hope for you too. So please join us next week, next Tuesday, June 4th at 3 p.m. on Zoom. Take this QR code to register. We'll drop the link in the chat as well. And discuss with us how to measure, how to quantitatively measure impact in crypto. Next, I'd like to announce that the exam for Giuseppe's live track is now open. So this is the final session in Giuseppe's program, and we'll open the exams today so that you can just go ahead and take the exam, pass the exam, and then mint your personal NFT proof of knowledge. I'll share more information how to access the exam, important deadlines, how to mint your NFT later in the session. So stay tuned. Just want to let you know that this is certainly the next step you should take for completing this live track. All right. This was it from my side. Giuseppe, the stage is yours. I'm very much looking forward to this final session.
Thank you very much. I'll share my screen 1 second. Can you see it?
Yeah, we can see the slides. Thank you.
Perfect. Thank you very much, and hi everyone, and welcome to the last discussion that we will have about this short module, let's call it this way, about dApp analysis and the complex system-oriented approach. The 4th episode is about incorporating software metrics and try a little bit to discuss like future studies. We started introducing the definition of complex systems, and we also continued defining what is the approach, the so-called complex system approach for dApps. And then in the 3rd episode, we started understanding how to analyze decentralized application of function levels and contract levels. We know that the decentralized application is made of contracts, and contracts can contain functions and they can call each other. We discussed about bipartite graphs, and we saw the power of using complex networks for also representing and checking how a decentralized application is working. And then last time we concluded our lecture with the possibility of adding additional information to these networks that we have. We know that we can represent a contract as a node in the network, and that node can contain additional information, so we can have even different layers of information in our network and in our representation. So today I will discuss a little bit about software metrics and why this information, these metrics, can be important when we study decentralized application or software in general. So this is the definition of dApp that we know very well, running on blockchain. So we have this distributed environment which is adding complexity, and there is no human intervention, and dApps are made of smart contracts. So we will look at what are these software metrics and why they are important, how these software metrics change when considering the size or the complexity of the decentralized application. And then we will analyze also correlation among these metrics, because there can be metrics which have, let's say, similarities. Let's start calling in a simple way, property of metrics. There is a tool that we developed in our lab. It's called Smart Metrics, and similar to dApp, the tool is able to read the contracts in the directory that we have, reading the source code, and then provide us a CSV file with the different metrics related to a specific contract. And this is the paper that I will discuss today with you, like preliminary results on software metrics that we analyzed for different decentralized applications. And I will start with the definition of a software metric. I told you during the first episode probably that we really like to measure. We like metrics. We like measuring things as engineers or mathematicians, physicists. Measures are important, are fundamental. If we have to study a phenomenon, we need to understand metrics for measuring and for studying this phenomenon. Software is quite complicated from this point of view, because we cannot touch software. It's elusive. We have code. It's very difficult to measure software. So software engineers and computer scientists defined and introduced the concept of metrics. Metrics are quantitative measures, and the help that they provide is related to understanding and improving, hopefully, efficiency, quality, productivity. So we can measure two things: the development process and the software product as well. And by looking at these measures, we try as much as we can to improve the aspects of software development: complexity, performance, reliability. But from the point of the software process, we can also improve the quality of, let's say, the daily work of software developers. So also human aspects in software development are extremely important. We can divide the metrics in two categories, those related to process. So they are focusing on software development process and they can relate to the efficiency and the productivity of the development team. Again, when I say improve the efficiency and productivity, I'm simplifying here because it's not only productivity and efficiency, it's also the quality of life of the developers there. And then we can have different measures. Amount of work completed, for example, in a sprint, time to complete a task, time to fix an issue, like defect density in a specific piece of like can be a class, it can be a package, can be a module. So these are metrics related to the process. Then we have product metrics. And in this case, metrics are related to the software product. And with these metrics, we can evaluate the quality, the complexity, how maintainable software is. I don't know if you have heard the term legacy code, for example. Legacy code, it's like usually companies are scared of legacy code because it's code which was written many years ago, and when there is legacy code within a company, highly likely there is a very limited number of people able to understand and maintain the legacy code. So having metrics and documenting the code and understanding how code is evolving is quite important also for maintainability. Example of metrics. The most common one and the most used one and probably the most well-known is line of code. Line of code is telling me the number of code that I have in a specific artifact. It can be a class, it can be a file, it can be a package, it can be the entire system. Usually when we are studying, for example, history of programming, of computer science, we probably, you are used to hear like lines of code of, I don't know, this specific system or operating system in the 80s, where, I don't know, this amount of code. And now we have millions, and the number of lines of code is giving you an information about the complexity, if you can say so. But we will see how reliable this type of metric is, because of course it depends on the language, on the programming language. It's like, even with languages, think about a book. I can count the line that I have in a book, and I can count the line that I have in a chapter, and I can count the line that I have in a page. Okay, so it depends what I'm trying to analyze. Then we have psychomatic complexity, coupling, cohesion. Today I will try to give you several definitions. I think there's a question in the chat. Sorry, I started seeing the questions now. Do you ever formulate time series based on these metrics? For example, temporal dimension could be understood as time when code is being added. Absolutely, yes. Time is fundamental. For example, understanding how the line of code or a specific part of a system evolved over time can be extremely interesting because it tells me like the changes applied to the specific part of the code, to the code base. So keeping an eye on a specific module and understanding how often this module is changing can be interesting. So time series here play an important role, and like many research activities can be done here. As I said, these metrics are important because we can identify areas that we can improve, for example. Line of code definition is total number of lines in the code. I have this example, the pseudocode that we used last time is an example, a very basic example of contract. Can someone tell me how many lines I have here? I want to perform a quick empirical experiment. Type in the chat if you like. Let's see if it works, this quick experiment that I would like to. Don't be scared. Remember, it's
6, 9.
Okay, as you can see, it's enough because we can see that there are two different type of two different responses here, 6 and 9. So if we count the line of code, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, because parentheses are code. 6 probably is 1, 2, 3, 4, 5, 6, ignoring parentheses. There can be another answer actually, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because we can, like, is the blank line code? Well, no, it's no code, but there are specific languages, for example, taking into account the way we indent the code. So as you can see, even a very basic metric, it's debatable in software engineering, like 6, 9, we have to agree here. So this is a very simple example, but I wanted to show how complicated it is also to measure like something that is here. We can count here the line of code, but we have different opinions. So in this example, we have 9 because we are going to consider lines where there is written something. So the thing is, when we analyze, however, we have to understand, what are you considering? What's the definition of line of code in your analysis? So all the time, when you're dealing with metrics, even if they sound simple, like line of code, it's better that you ask for the definition. So you have to say, line of code, how are you counting them? Because as you can see, there can be different results. In the study that I presented at the beginning, it's available. I will give you the link and I will post in the material. It's an open access paper. We considered metrics at contract level and metrics at function level. As you remember last time, we can build the contract to contract, like the contract graph, or the bipartite function contract or function graph. So here, we consider contract level metrics and function level metrics in the centralized applications. So we have a data set of the centralized applications. Each decentralized application has a certain number of contracts, and then we calculated contract level metrics and function level metrics. Remember, a contract can have more than one function. So let's try to quickly understand contract level metrics. Inheritance depth. Inheritance depth. So now I will be throwing several definitions, please. I apologize from the beginning. I beg you pardon, but it's useful to have an idea of what I'm measuring. Definition of inheritance depth is measuring how many layers of inheritance a contract has. What does it mean? Level of inheritance in a contract. If we look at the contract that I showed earlier, there is no inheritance. So the depth of an inheritance tree is 0. What does it mean? It means that this contract is not is not inheriting using, let's say, function from other contracts that we have. But now let's look at this example. Here we have base contract, which is doing something. And then look here to the derived contract. Simple storage, there is this keyword, is base storage. Again, this is an example, okay? Don't take this code as perfect Solidity code. I'm explaining to lay to a lay person the meaning of metrics, simplifying a lot. I'm saying here the meaning is simple storage is a new contract which is inheriting all the functionalities that I have in base storage. So simple storage is also a base storage, but specialized. This is called inheritance. So the new contract, simple storage, is inheriting all the information and methods that I have in base storage. And however, simple storage is specialized, is a type of base storage. We say this in programming languages. Now, simple storage is inheriting from base storage. So the inheritance depth is 1 because it's inheriting from base storage. And in this way, this metric is telling me how like the depth of the inheritance that I have when I'm analyzing a contract. This is the UML representation. It's called UML representation of the, I'm forcing this because I'm representing 2 contracts here. We don't have UML for smart contracts. We can force it a little bit. So we have base storage, and we know that simple storage is inheriting from base storage. This is the meaning of the arrow that I have here. You can guess, and you can tell probably, that if I have different level of inheritance, the situations, it's a little bit more complicated. Therefore, having an understanding of this metric is important. 1, so 0 means the contract is not calling another one. Let's put it that way. It's quite straightforward. 1, there is another contract that I have to consider. 2, even more, there are 2 contracts. I don't know if you get the message here, the importance of this metric. As always, stop me if the concepts are not clear. I understand that today are very technical, so please don't be afraid. Write in the chat, jump in the conversation, stop me whenever you want. Another measure is called coupling between contracts. Usually it's calling, like this is a metric that we introduce in the paper because it's coupling between classes, but here we have contracts. And this indicates the number of other contracts that a contract interact with. It's not like inheritance, because look at this example. I have 2 contracts here. Contract 1 on the left, data storage, and contract 2 on the right. I can see the simple storage is interacting with data storage because there is a field data storage in the contract 2 related to data storage, the contract, and then there is a function which is doing something there. So the coupling is present here because it means the 2 contracts are collaborating somehow. Simple storage is interacting with data storage, and simple storage has a CBO coupling between objects, but in this case, coupling between contracts of 1 because it's interacting with the other contract. Coupling between contracts of data storage is 0 because data storage is not interacting with the other one. If you look at the code here, data storage doesn't care about simple storage. A simple storage is interacting with data storage. Is this clear? So CBC here of contract 2 is 1, CBC here is 0, because there is no interaction from this contract. I hope this is clear. So in this example, the CBC of simple storage is 1. And we can see again in the diagram the interaction that we have. And we can see that this one is interacting with data storage and not the other way around. Another metric, now, as I said, I'm throwing in different definitions, and we will see why I'm giving you all this information. This is called state variable count. I'm counting and checking the number of state variables that I have in a contract. And easily, the higher the number, the more complex is the contract interaction that I have. What are the variables? State variables are the variables that I have here in a contract at the beginning usually. You can see that I have store data, data string, owner. These are three variables that I have here, and they are called state variables. So if I count them, the state variable count for this contract is 3, and it's not complex. It's not a complex. It's moderately complex contract. More state variables, though, are increasing the complexity. Therefore, I have to be careful when when dealing with this state variable. Okay, variable in a contract are an indication of the complexity. Then another metric is called average local variable, and I have the average number of local variables which are used across the functions in the contract, and it's how much temporary storage a contract is using. You can see here, well, I have a variable is local to a function when it's inside the function. It's we have storage data is it's called global variable because it's for the contract. Function set can see this variable. Result, like the function get, can see this variable. This temporary one cannot be seen by this function. Okay, this is the difference. So the local variables are important. Another metric is max local variables, and it's the maximum number of local variables that it's used in any single function within a contract. And it's telling me the complexity of individual function here. In this case, I have in complex function, I have A, B, C, 3 local variables. In simple function, I only have a result, which is 1 local variable. So 3 local variables in complex function, simple function is 1. The max is 3 because I have to take the maximum. And this is an indication of if I'm checking the function, but it's a contract level, okay? I will have the max local variables for a contract, considering the local variables used in a specific function. Questions? No? Okay, good. I hope it means that you are following. As I said, so, stop me.
Feel free, everyone, to give us a thumbs up or a note in the chat. This is helpful to understand if we are too fast or too slow. Thanks.
Absolutely. This is easy. Number of functions. I have a contract, and I count the total number of functions that I have there. I can understand also that this set definition I'm providing can be boring, but I'm sure you will understand how useful they can be. Especially, keep in mind the graph that we saw at the beginning, all the nodes connected, and all this information which are for a node. So you have a node and then a set of metrics related to that node. So we are adding additional information in our graph, and this can be extremely helpful when studying our decentralized application. Number of function, again, is like here you have a book and you tell me the number of chapters. Similar, okay? And of course, if the number of chapters is quite high, you are expecting a bigger book. Similar for a contract. If I have a very high number of functions, my contract probably will be bigger. And if I have more functions, usually I have a more complex and feature-rich contract. I mentioned several times that function with a very high number, a contract with a very high number of function, usually is not very good because I'm not delegating responsibility, and it will be a God contract with too many responsibility. And this is similar, like in software development, God classes should be avoided because you are not delegating. In this example, I have Victor, please go ahead.
Actually, just because you said it and I thought about this before, can you actually compare like classes to contracts? Like, would you say that these are synonyms when you look in Solidity and compare it with another language, maybe Java or something?
Thank you very much for your question. No, they are not synonyms. No, we cannot compare. They are useful. It's a useful comparison for understanding the concept, but we can't say that a contract is a class or a class is a contract. They are different concepts, even because like class is specific term for object orientation. Here I'm forcing a little bit the concept because there is of course, it's possible to compare these two concepts, but they are different. Class, there is object orientation there, and all the aspects of the object orientations. Contracts, similar, but they are not the same. They are not synonym.
Okay, thank you.
You're welcome. So here, sorry, there's another question.
So I have a question, but it's not, maybe that's not the ideal point for the question, but I will forget it if I wait.
No, it's fine.
Later, I'm sorry. So I was just thinking, here when you're showing the sort of simple examples of the code, of the functions, of the contracts, and so on, it's sort of like each of them is I don't know what would be the best description, but I'm imagining that a person is writing all of their code, all of their contract, and then let's say you compare it with some other piece of software where maybe there were some frameworks used, which sort of do a lot of like abstracting away of some of the structures, and then you might end up with maybe very similar sort of structure hierarchy in maybe some areas of code, and I was thinking that might maybe add one more layer of hierarchy that you couldn't think of. That's on one hand. On the other hand, it might introduce some sort of like structures which are not maybe fully optimal in terms of the code on its own, but it's just faster and maybe in some way safer if you use frameworks, and some things maybe are just more complicated because some things are abstracted away. Maybe they're not always have to be like that. But that also come with maybe like vulnerabilities at a different level. So I was wondering, do you ever think about those situations where the structure is maybe different just because people like software developers might be using some frameworks?
Thank you very much for your question. It's extremely interesting and it's a very good one. Absolutely, you are right. So the thing is, when you're analyzing a system and comparing the system, usually you understand if the system are similar. So if I, for example, comparing I don't know, 10 system written in Python and there is a specific framework, then, and I know about that framework, I get that information also in the metric distribution because I can see that everyone is starting from the same level, okay? So a framework is within the analysis, the use of a framework. Also, here I'm simplifying a lot, providing the idea of metrics that we have. There is also, we usually use a lot patterns, design patterns. So we are able to understand patterns, and these are extremely helpful for understanding if there is a specific common knowledge. We read common knowledge, for example, as a framework used in the specific development. And about the structure, again, metrics can give you an understanding of the structure as well. There are many metrics, and therefore you can get an idea about, there is a simple class, but however, the number of line of codes are quite high. Even if the functionality are simple, it means that there is something being used there. So it's possible to detect also the use of framework. Framework can, then you said framework can maybe introduce vulnerabilities. Well, that's always possible when we are using let's call them third parties, which can be APIs, or it can be a specific way of even a framework if you are developing using a framework. But usually, things that are frameworks usually are used by many developers. Therefore, also best practices are developed in that way. If the usability is high, also the reliability follows usually. But you are right. You need to put things in context. Measuring software is difficult. So the more you know, the better. Starting from the definition of the metric and starting from the context. Manual inspection is something that you have to do all the time. And by doing manual inspection, you can immediately tell if there was some specific framework used in that development, for example. Did I answer?
I think so, but I have one more question. I'll try to be quick with this one.
Yeah.
So I think from what you were saying, I got a few thoughts, and I just thought I'll maybe check on them. So let's say that that you look at I don't know, maybe an AMM where each new liquidity pool that is created, that always have to be everything new that happens here has to be created from using I might be forgetting some words, using factory pattern. So it's like you cannot write new pieces of code here that are very different. So let's say somehow, I'm not sure if this is always easy to do, but anything new that appears, there's lots of restriction. And here I imagine the fact that there is restrictions on how new contracts can be introduced, that might be easier to, I don't know, maybe easier to prevent rug pulls, or easier to prevent some rogue contracts, but there's maybe more centralization of this system. And if you compare it to a system where maybe there is more flexibility as to what contracts can be written, that means that on one hand, there is maybe more opportunity to write things in a way that maybe it will not be noticed that there are some, I don't know, bad constructions. I think I'm not even sure if this is just me thinking loud or if this is the question.
No, I understand your point. So you are concerned about the possibility of comparing, for example, two different systems. Let's put it that way. So I have a system doing something following a specific rule, and then I have another one completely different with other rules. Can I compare the two with metrics? Is this what you're asking?
I guess that was one of the thoughts.
Exactly. So again, you are not comparing apple and oranges here, because you are using metrics and the same definition of metrics into specific metrics. Probably the distribution of the metrics will be different. Therefore, you can discriminate specific aspects of the software development. And that's why metrics can be useful. Metrics can discriminate specific, even methodologies. So the metrics can, you can plot the distribution, and you can try to understand how they behave. Of course, there are patterns, like a line of code follow power laws, no matter what, but there can be different type of distributions. So you can compare different systems with metrics. It's something, of course, context is fundamental. Okay?
Mm-hmm.
But we can keep...
And I suppose that also here you get a lot of useful information in terms of, like, I don't know, from the network analysis in the system, you see that, I don't know, these are the types of vulnerabilities that we are more likely to have, and maybe they are very much sort of reflecting the fact that maybe one is more centralized, the other one is not, and so on.
Yes.
Right?
Yeah.
Okay.
It's something. Also,
I found the ticket.
one thing. It's also.
Okay.
Yeah.
Sorry. It's empirical. All the studies are empirical, so it really depends on the empirical study we are performing. So here, number of functions. We have 4 functions: set, get, increment, reset, and number of functions is telling us inside to the range of operation that a contract can perform. Let's move to the metric that we have a function level. I will go quicker here. Number of parameters is telling me the number of parameters that a function takes. Higher number, function is more complex, and they can be more difficult to understand and use. Here we can see we have this function, simple function, 1 parameter. Here there are 3 parameters. Okay, what are parameters? Parameters are simplify as much as possible the concept. If you're not familiar with software development, you can see a parameter as a mailbox. So you put something in, and then someone can take what's inside and understand. Usually 1 person, 1 mailbox. Think about if you have many mailboxes, it will be complicated to get an understanding of all the mails that you are getting. So again, very basic and not complete example, but probably gives you an idea. So see parameters and mailboxes. Here, simple function, 1 parameter, complex function, 3. The name is helping, probably complex function is more complicated than simple one. And the number of parameters, it's an indicator. Then we have another metric at function level is called nesting depth. This one is representing the depth on nested loops and conditional structure that I have within the function. What does it mean? Let's see the code, and it's clear and easier. We have shallow nesting. So we have a conditional expression here, and if x is larger than 10, I increment. And here I have if x bigger than 10 and then less than 20, then I have a loop where there is another conditional expression here within the loop. So you can see that the nesting of this function is higher than this. Here is 1. Here I have 1, 2, 3 level of nesting. In this case, the higher nesting depth is leading to complex and less maintainable code. Think about someone else reading the code, someone who didn't write the code, trying to understand what's happening there. So the depth of nesting should be under control, okay? Avoiding complicated functions, because otherwise maintainability goes down. Function calls and other metrics is telling me the number of times that a function is calling another function. And if I have frequent calls, then there is a complicated behaviors of interactions. Again, function calls, why are important? Think about yourself doing a specific task, and if you are well organized and you know what to do, you go and perform your task. If you need the input of someone else, you start calling on the phone other people, and this is going to slow down your task. Again, very basic example, but it gives you an idea. When you have to rely on other functions or on other people for doing something, the level of, let's say, complexity is growing. And again, the trace of what's happening can be complicated here. So I need to consider what's going on. Let's try to see this code. We have three functions: add, multiply, calculate. The function which is calling other function is obviously calculate. This one is not calling other function. This one is not calling other function. Calculate is calling add here, and then it's calling multiply here. So one function call, second function call. In this example, I can check, and it's easy. Function call like 2 for calculate, it's quite easy to understand and to maintain. But when the number of calls is high, then number of interaction, tracking all the interaction can be challenging and not that easy. Cyclomatic complexity, this is a very nice one and largely used in software engineering. Measures the number of linearly independent paths through a function source code. The definition looks more complicated than when we will see the source code in a moment. Higher values, complex functions, and when there is high cyclomatic complexity, I have more branches in the decision point, and again, complexity is growing. Here, I have the function, simple function. I have here, look, if x is larger than 10, I increment, and then here, look the cascade, like the different branches that I have. I have one if, second if, then I have an else, and then I have an else. So here is just basically 1, okay? But here, 1, 2, 3, 4. These are the linear path that I can have, the independent. Simple function has cyclomatic complexity of 2. Why it's 2? Because I have one decision plus 1. Plus 1 is because I enter the function, and that's already like 1. So I enter the function is 1 by default. Then there is the conditional expression plus 1. Here I enter the function 1 by default, and then the 4 point that I have. So here, complex function, higher cyclomatic complexity. And again, if the cyclomatic complexity is higher, these functions are more difficult to maintain. Local variable count, they indicate the number of local variable within a function. And the problem is, if I have a very high number of variable count of local variable, the local variable count is high, it means that the function is complicated, because I need to probably store more information. Look here, I have here one local variable, here 1, 2, 3, A, B, C. Okay, of course, this one is more complicated. It's doing basic operations, but if I have many local variables, local means it's local to a function, the complexity is higher. And as you can see, simple function, 1 local variable, complex function, 3 local variables. Okay, I gave you all these definitions. Why? Because the goals of this study that I'm trying to describe today is, can we analyze software metrics at control level, function levels, and get an understanding of what's going on in the centralized application? And what's happening with the distribution of the metrics? Are they correlated? Do they change? And this is also related to the questions that you were asking earlier. We categorized the decentralized applications with different sizes. We have almost 70 decentralized applications in our data set. But first thing, can we compare all the decentralized applications? Here we have the number of contracts in our data set and the number of functions. As you can see, they are quite different. So one thing that we have to consider is size. Can we compare all the centralized application together? Well, we could, but do we get meaningful information with this? It depends. In this case, the experiment was, can we study metrics distribution for small dApp? Small dApp means there are 10 contracts. Medium, there are 30 contracts. Large, there are 50 contracts in the dApp. That's the classification that we have. Small dApp, medium dApp, large dApp. And then we classified the number of functions that you have. Of course, they are similar. If a dApp is small, there are fewer contracts, then also the number of functions is fall in the small category, and so on. Second step, so first step, we have a data set of the centralized application, and we divide the data set in small dApp, medium dApp, large dApp. And we studied the number of contracts and the number of functions, as you can see here in the box plots. Then we said, okay, let's evaluate the metric distribution, because first we need to understand if they are normally distributed or not. So we performed several tests to understand if they were normal distributed or not before, because we want to apply correlation. We want to calculate correlation, so you have to check for normality first. They were not normal, therefore we used Spearman correlation. Now, this is a heat map, and here I have the metrics a contract level, and here the metrics a function level, all those that I explained earlier. And if there is red means that the correlation is perfect, but as you can see, inherit sum depth here is perfect correlation with inherit sum depth, okay? And so on. The diagonal is something that we don't have to consider. So we can see, however, that if it's in red, it means that the correlation is getting high. If it's blue, there is no correlation, or even negative, because correlation goes from -1 to +1. And we can see that the coupling between contracts is as weak positive correlation with inheritance depth. It means that if the level of inheritance is high, also the coupling between the contracts probably is growing, and it makes sense, okay? Because it means that several contracts are using other contracts. And then we can see another positive correlation is the state variable count, the variable that I have in a contract, and the coupling between contracts. The more state variable that I have in a contract, it means the level of complexity is high, and the interaction with other contracts gets also high. And also there is a positive correlation with the state variable and the inheritance depth. And then we studied the correlation among function metrics in small dApps. The goal, though, was are these correlations staying also for the other size, of dApps? So this is the small one. Now look visually. We will go in deeper details after. These are the mediums. Look at the colors. These are the medium, so larger dApps, and these are the large. Correlation is changing. So even if we are in the, more or less in the same range. However, what I wanted to show here is that we need to be careful when using metrics. This is very related to the question we had earlier about, can we really compare two systems? Because I can see that I need to be careful when using metrics, also to the dimension of the system that I'm analyzing. Because if I compare a small dApp with a large one, well, the correlation of the metrics, they are the same metrics, but the correlation among metrics in large dApps is different, slightly different, to the correlation that I have in small dApps. Because if we look at the heat map, I don't know if you can get it, but look at the colors here, without reading. we look that colors are changing slightly, but they are changing. And those are the same metrics. The difference is not extremely high, because otherwise it will mean that metrics are completely useless. But there are differences. If we consider the correlation among metrics and the different sides in terms of contract of the dApps. So the message is that we can use metric for understanding the behavior of what's happening, but we need to put all the information in context. And also classification from the point of view, like a simple one, like the dimension, is something that we have to consider. Of course, this was a preliminary study, and the data set is limited. There are many threats to the validity of the study that we have to take into account. And there is a correlation between the size of the decentralized application and specific software metrics. And we can see that there is a complexity when the decentralized application is like increasing, it's scaling. And the higher coupling between contracts in large dApps, suggesting, of course, there is more interaction with other contracts when the size of the decentralized application is growing. And if I have many, I have a higher level of coupling between contracts, also the security risks is increasing here, because contracts are talking to each other more. And this is not happening as much if I look at the small decentralized application with a limited number of contracts. Also, correlation between number of parameters and local variable counts could have implication on the gas cost, for example, in Ethereum-based decentralized application. So that's another thing that we could look at and we can have information about. And our higher frequency of function calls when there are larger dApps, then higher degree of modularity, again, essential for understanding complexity and managing complexity here. So these preliminary information can guide us for future analysis, for understanding how we could study metrics in relation with all the complex network that we have, to better understand how to develop our applications. So we see that inheritance step and coupling between contracts increases when the dApp starts scaling up, and we need to keep an eye when this is happening. Larger dApps can have also more complex contracts, not only more contracts. Contracts are, the number of contracts is higher, but also the complexity is higher. And of course, this can introduce security risks. And function level, we found a consistent relationship between number of parameters and local variable among all the different dApp sizes. And also negative correlation between cyclomatic complexity and function calls. This was observed, and we are studying this in deeper details. We are performing now studies for understanding better the both coupling and cyclomatic complexity in deeper details, also because this is a very preliminary study with the limited data set. And the suggestion was this possible trend of decomposing like complex logic into smaller function in larger decentralized application. It means that developers are thinking about the structure that they want to give to a decentralized application. So takeaway from the very technical discussion that we had today. Metrics can be helpful for improving and optimizing your system, that software in general. It gives you an idea of what's happening in the code base, and then you can optimize for results like optimization as well. Maintainability. Metrics are helpful for understanding like the code maintainability and for improving and enhancing the maintainability and to simplify debugging as well. And prediction as well, helpful for predictive studies. You can predict by looking at the metrics like defect, vulnerabilities in our case, and plan for better development practices. And as I said, all the conclusions I have presented quickly the results, the preliminary results obtained. But if you want to know more and you want to read better and understanding better the results and ask questions, of course, I'm always available. This is the paper which is available online. I will upload also in as material, but it's open access, so you can access the paper on the web. And questions now. Victor.
Sorry, it's again me. So basically, I'm just kind of, I wanted to ask, is it possible, again, I'm not a developer or engineer, but is it possible to kind of take like some kind of sample of protocols or smart contracts in general that have been, hacked or somehow have shown vulnerabilities that have been exploited, and then use them as some sort of control group, so that you have like some form of to test your hypothesis or your system to say, okay, because you make an assumption that because there are in the large dApps that you say have a lot of functions, for example, that they might be more prone to be exploited because they're more complex. And so I just wanted to, I don't know if you understand what I mean, but I just wanted to create some sort of like control system where you can say, yeah, actually it's true, like from our sample, all of them that have been much more prone to exploiting, to being exploited, they actually show exactly the characteristics that we would expect.
Absolutely. So all these experiments are empirical. Okay, so it's called empirical software engineering. What we do is we have data sets where there are information about. It can be, for example, you have a smart contract, and then you have all the metrics, and then find like a column where you have information vulnerable, yes or no. And then you can play with predictions and models for understanding if you can predict the vulnerabilities by looking at the metrics, for example, or adding more information. And of course, if there are for doing predictions, you need to check smart contracts with known vulnerabilities and piece of code, like classes, for example, in a system, if you are doing bug predictions, where bugs are known and detected. So that's something that absolutely you have to do. So and having code which has been already analyzed, and we know that there are bugs in the code and the bugs have been classified or vulnerabilities, it's something that it must be used for understanding if, for example, metrics have predictive powers. Okay, so
when you look at specific bugs, though, like when you look at specific known bugs, then you basically, you could have them also in small dApps, what you refer to as small dApps or mid-sized dApps, right? So basically, that's why I was saying, like, I was rather kind of pointing at the correlation of, just independently, like, don't even look for, like, just choose like dApps where you're blind towards it. You don't know how the size of the category you want to put them in, and you just know they've been exploited, and then you kind of run it towards, you use them and as a control, and you run it, and you then say, oh, okay, they actually have the characteristics. Now we understand that there's a correlation between what I would expect to have vulnerabilities.
I see your point. No, but in this case, in the study, we weren't looking at vulnerabilities. We wanted to understand if the correlations among metrics stays the same with the size of the dApps. So the goal here was a little bit different. we weren't looking. It's true that metrics can be also used for understanding vulnerabilities, something that we are testing now for like at the moment in our lab. But in that experiment, that was about metrics, and the question was, are the correlation among metrics like the same if the size of the dApp is changing? That was the question. So it was a little bit like an exercise on metrics.
Yeah,
like
sure.
no
That's
really
good.
vulnerabilities.
Thanks.
You're welcome. Other questions? No? Okay, then I would like to.
I still, if there's nobody else with questions, I always have questions.
Yeah, absolutely.
But some of those questions are not super precise because I think I'm sort of like still processing what you were saying. So like building up on the last question and your last response, I understand that in this particular experiment or the research, the goal was only to see how much the different metrics sort of stay similar or change with the size of the dApp, right? To see if there are some metrics that you could then maybe treat as ones that are more constant, so then you can maybe use them to test your systems. How to say? So then if you have new systems and you want to be able to say something about them, say if they're, I don't know, good, bad, more prone to attacks, you could say like, well, in this particular case, these statistics seem to be like huge outliers to what is our like base from this study that you mentioned. Am I right here?
Yes. Yeah, the idea was to understand how if metrics were holding, looking at the size and seeing also, of course, correlation is a very basic example of understanding if metrics are like working together. There are more detailed, like principal component analysis, for example, for feature selection, understanding if like there are information which can be summarized. So if you don't, there is no need to bring to check all the metrics that I mentioned today, for example. But I think it's important to have an idea of all the different things which is possible to measure within the code and understand the usefulness of metrics, especially when put in a context of a complex network perspective. So today, like the final episode was about like we started understanding complex system. We know what is a dApp. We built the network with all the nodes linked to each other. Then we can add information to those nodes, and providing this additional information is not only giving us the structure of how these contracts are and function are working together, but we can also understand the different metrics and the different information which each node has in the network. And of course, we can perform additional analysis and refine all the studies that we can do from like this static point of view.
All right. So now you're looking more at some specific metrics, but earlier on you were talking about the earlier step, which is mapping your complex systems for the specific dApps. And then when you were talking about the complex systems, you were talking about sort of various properties of that as a like complex system on its own, not necessarily just the application, but the fact that, like, I don't know, what's the measure of centrality, what's the measure, like sort of like network network metrics. Did you at any point find that, for example, you had some dApps where those systems were very, I don't know, weird in terms of, or outliers in terms of this sort of purely complex system metrics, and therefore maybe you decided to exclude them from this research where you concentrate on the app specific metrics? I don't know if my question was clear.
Yeah. No, really, no. We didn't identify like specific outliers, but definitely something that we should look at, and it's something that actually we are doing. We are at the moment what we are doing is building a reliable data set with. At the moment, we are working on creating a large data set of dApps with robust dApps, which are like news, and also creating this data set is not straightforward. And then when we have a solid data set, we will start analyzing also outliers and understanding what's going on there. But definitely it's something that we are looking and we are keeping in mind.
And I'm curious, were there some maybe like specific network level metrics that you could see would change in proportion, just like for the small dApp, medium dApp, and big dApp? Were there some of those, I don't know, like maybe small when we're more connected or something like that?
At the moment, the data set that I presented today was used only for the metrics. There are information about the different type of networks in the other papers that I uploaded last week. I will send you the link again. And but we are investigating the dimension and the network aspects in another work that we are doing right now. It's an extension of the previous one, but again, also the classification of small, large, and medium must be refined because the data set, the first data was quite small. 70 is not a big number, so we need more decentralized application for more reliable empirical studies.
And let me just check. These are all the apps on Ethereum, right?
Yes. The majority, yes, a very small number on other platforms, but the majority is Ethereum.
Do you have some sort of, I don't know, intuition that you would expect those things to be sort of similar on other blockchains, or do you think that it might be that it's not necessarily so because blockchains maybe are so different than?
No, at the moment we didn't. So I don't know how to answer because well, I'm expecting similarities, to be honest, from a personal, but it's a personal opinion, and it will even because mainly decentralized applications are developed either on Ethereum or in like in Ethereum-like style. But it's not. This is not. Like an answer, I would say. We need to investigate. At the moment, we mainly analyze the Ethereum dApps, so I don't know because I don't have the data related to other platforms.
Awesome, thank you.
You're welcome. There's a question in the chat. Can you remind what the input for smart metrics and the input is the Solidity smart contract. So we have the code, and then that's the input, and there are parsers checking the code and providing the data.
So does that mean that you can just go on, I don't know, get any kind of a smart contract, like you can go on CoinGecko and just say, okay, I want that particular kind of project, and then you just copy paste the contract address, and from that you could
No,
theoretically
the code.
study. Oh, you need the
you
code.
have to. You
Okay.
need the code. Yes. Yeah.
All right. Thank you.
You're welcome. Other questions?
So just one, if nobody has other questions. So what are your next steps?
Sorry?
Just curious, what are your next steps plans in terms of research?
So at the moment, we are focusing a lot on vulnerability prediction. So we are trying to understand the elements which are improving the prediction powers of vulnerabilities. So we have smart contracts, we have dApps. We want to understand, can we predict vulnerabilities? This is a $1 million question. And we are, again, collecting data, building data sets, and metrics, and as many information as possible for understanding how we can improve this vulnerability prediction. And another step that we are building all these tools, because as I said, many auditing processes are manual at the moment, and helping the auditing process of smart contracts with automatic tool is something that we are trying to do. And these are the two main directions that we are following at the moment.
Awesome.
Okay, I can't find any more questions in the chat and raised hands.
Okay, then, of course, as I said last time, feel free to reach out and if you have questions, even ideas, because in our lab, we are very open to collaboration. Research is collaboration. Research is new chats, new ideas. So more than welcome to reach out, send an email, message in Discord, and remember there are only positive ideas and comments. So I hope you enjoyed this 4 episodes. I know the several parts were very technical, but I hope that you got an idea of what we are doing in our lab and the different activities that we are doing in our research. And thank you very much for your comments, questions, and for attending.
Yeah, I would say same to you. Thank you for hosting these sessions and for running or sharing your knowledge with our community. I think we just entered a new area of exploration, the token systems that are implemented in smart contracts and how we can explore. And I think this is only the starting point. There's, I guess, a lot to explore. How can we not only address software vulnerabilities, also vulnerabilities on the economic side and economic attacks. And this is years and decades probably for research to be done on this subject. Yeah, I'd like to drop some links here to everyone here in the session, just in case you'd like to say thank you to Giuseppe. And if you enjoyed these sessions, give him a shout out on Twitter. I just dropped his Twitter link, and we'll be happy to retweet and spread the word. And I'd like to share now how you can take the exam, because obviously this is the final step you can take to prove your freshly acquired knowledge in this sector. So let me pull up my browser window. I think you can see it now. And so the exam is accessible now at tokenengineering.net. So you just go to our webpage and click on Explore Courses, and there you'll find the dApp analysis, exploring the complex systems-oriented approach live track with some more information on deadlines. So Number one, this is again Giuseppe's link. So in case you'd like to get in touch or stay in touch, this is the route you can take. Then there's again the link to the study season information hub, where you can find all the recordings and the session slides to go back to the learning materials. And then here's the deadline to pass the exam. It's June 24th. So you have almost a month still to take the exam and pass the exam. And then you're eligible to mint your NFT. Keep in mind, if you go now, today, directly to the exam and you pass it, you'll have to wait until next week, because only then we'll open the free minting. We are just updating our infrastructure. This will take us some more days. Free minting will be open next week, but still you can take your exam, and once you've passed, this information will be stored and nothing is lost. You just have to wait until you can mint. Okay, and then most importantly, via and with your new NFT in your wallet, you'll be eligible to take part in the voting for the fellowship prize winner. So we have this 10K reward for the fellowship prize winner. We have the 4 candidates, Giuseppe being one of them, and we want to award the live track the community found most valuable and help the award winner to continue research and continue contributing to the field. And that's why, if you'd like to say thank you to Giuseppe, for example, it's important that you vote, and your NFT will give you additional voting power. So we'll announce anything related to the voting via Twitter, of course, also on the Discord, and you'll get reminders via email as a registrant to the study season. So you won't miss it, but just to mark your calendar, we'll open the voting on June 18th. So this will be after you have been had some time to mint your NFT, and we'll close it on June 25th. So 1 week for voting on the fellowship prize winner. Please keep it in mind. It's our way to give and get in the community, and your best way to say thank you to the fellowship candidates. More details, there are no fees to mint your NFT. It's free, and anything related and more links about TE fundamentals can be found here. And then let me just show how to access the exam. So you have to log in. You already have a TE Academy account. If you registered for the study season, log in at tokenengineering.net and click on Go to Course, and then you'll see the exam. It takes a moment to load. So don't be, look, I have to enroll again. So you click enroll. Sometimes it's a little bit slow, but be patient. And then you'll ultimately land here. This is the course, and this is the exam. You click here, and then you'll see the exam, and you can just launch it. You have as many attempts as you like. So even if you fail in your first attempt, you can take it again as often as you want. You go to start, you launch the exam, and then you'll get questions. It's multiple choice. You answer and just click on next question, answer next question, and you can also go back. And it's in total 25 questions, maximum 1 question answered incorrectly. And once you've submitted the result, you'll get the outcome, right? So in case with my first attempt or my third look, I failed. But then you can download and get a feedback report like this. So you'll see which questions you have answered incorrectly. And you can try again. And this Go to My TE Academy profile will guide you back to TE Academy, where you then, in case you were successful, can find the course again. So this is the section in your profile section, My Courses. It's also here, My Courses, it shows where which courses you are enrolled in and which courses you have completed. And I have already completed the exam for Muhammad's live track. And equivalently, you'll see Giuseppe's live track here in case you have been successful. And then you can mint at the moment, since we are updating our infrastructure, it will give you just this information that we'll open minting on June 6th. But this is the steps you take to mint. Final comment, you have to have an Ethereum wallet connected with your profile. And this is my wallet address. It's an Ethereum wallet. It's immutably tied to your account, again, to limit attack vectors. So, and the NFTs are non-transferable. So it's important to read the instructions on our FAQs on tokenengineering.net to understand how this works and to select your wallet carefully, store your private keys carefully, because this is your track record, and it can be important now and in the future, so don't lose access to your NFTs. Okay, I stop and let me see if you have any questions on the exam or the wallet, the NFTs. Looks good. I bet you're already taking the exam, so go ahead. And yeah, fingers crossed. So I hope to see many students being successful. And again, we'll meet again for the voting, I'd say. We'll all meet at EFCC in Brussels. And Giuseppe, for now, thanks again. Let's stay in touch and let us know if you have updates on tools and approaches for analyzing dApps, and I hope to see a lot of progress here and interesting approaches to come up with token systems verification. Thank you so much, Giuseppe, for the sessions in the study season.
Thank you very much. It's been a pleasure. Bye, everyone. Thank you.
Thank you
very much. Thank you. Bye.
See you soon. Bye.
Thanks. Bye.
The recording has stopped.